bits and output it in an array. So for given number, for example, for 2, 0 it's 0, and for 1, because it's in the range of 0 to 2 is inclusive, so 1 there's 1 bit, 2 we can see there's only 1 bit, so that's the output. If we take a look at this one, same thing. So here we have 2, we have 1, we have 2, so that's what we have. So we can do with so many different solutions with this one. We can do dynamic programming, we can do bit manipulation. Since I'm covering bit manipulation in this playlist, we'll just do with bit manipulation approach, specifically with Brian Kernighan's algorithm. So let's jump into this. We need our array. So what we are going to do, we are going to count bits. So with AND operator. So with AND operator, if we take a look, let's say for given, let's say for this one right here. So if we see this one, when we are taking 2 and 3's AND, we can see that it becomes 1 and 1 becomes 1, and 0, 1 becomes 0. So this 3, if we are trying to see 3's on the next iteration, 1 is dropping. So when we are taking 3 and 2, this was the output of it. So we can do this approach iteratively and count the bits, because like every time when we are doing it, we are seeing 1 bit drop. So we can get a helper method which will give us the count of it. Count bits helper. We'll take num, and what we are going to do, we'll do the count of it. So while eventually in this approach, when we are doing a while loop, in the end it should equal to 0. So we are going until this is not equal to 0, and for num and equals to num -1. So that's how every drop in this one, it's dropping bit by bit, and we will be just counting it on the way, and in the end we'll just return the count of it. So what we are going to do, and for this range that they were saying, we'll do the loop of it. So I inclusive n, I plus plus, and then we'll just call our helper method. So answer for each of this array, we'll just do count bits helper and pass our I into it, and in the end we'll just return answer. Initiation, okay, there we go. Perfect.